Hi, I'm Brian, and this is the Pressure Control Loop. In this video, we'll cover utilities, required safety equipment, major components, and explain how this pressure control loop uses split-range control to automatically maintain pressure. By the end of this video, you should understand the purpose of each major component and how they work together. The trainer requires three utilities: 120-volt electric power, process air, which simulates methane flowing through the process, and instrument air, which supplies clean, regulated air to operate the pneumatic control valves. Although both are compressed air, they serve two different purposes. Process air is the simulated process fluid, while instrument air is only used to operate the control valves. Before operating the trainer, don the required PPE, closed-toed shoes, and safety glasses. Gloves and hearing protection are optional. We'll start with the process air supply, which represents methane flowing through an industrial gas process. The supply pressure regulator. The supply pressure regulator adjusts incoming process air to the desired operating pressure before it enters the system. The process air enters the pressure vessel, V440. This is the pressure we're trying to maintain automatically. There's a pressure gauge on the vessel to tell us what the pressure is, and also a pressure transmitter. The controller compares the measured pressure to the operator's set point. If the pressure is too low or too high, it calculates the correction needed. Instrument air regulator. Separate from the process air is the instrument air regulator. It supplies clean, regulated air used only to operate pneumatic control valves. These are the control valves here. These are split-range control valves. One controller operates two different control valves. The supply control valve opens when the vessel pressure is too low, allowing more process air into the system. The flare control valve opens when the vessel pressure is too high, venting excess process air to the simulated flare. Think of it this way: one valve adds pressure and the other removes pressure. The controller automatically selects the appropriate valve to maintain the desired pressure set point. SCFH rotometer. SCFH stands for standard cubic feet per hour. It's a common unit used to measure gas flow because it references standard temperature and pressure, making flow measurements consistent and easy to compare. Pressure relief valve. This is an independent safety device designed to protect the pressure vessel. Vessel pressure rises above its safe design limit. The PRV automatically opens to relieve pressure and help prevent equipment damage or vessel failure. To summarize, the pressure transmitter measures vessel pressure. The controller compares the measurement to the set point, and the split-range control valves either add process air or vent excess pressure to the simulated flare. The SCFH rotometer lets us monitor gas flow, and the pressure relief valve provides independent overpressure protection. This trainer demonstrates one of the most common pressure control strategies you'll encounter in the process industries.